All right, so hopefully you've taken your Chapter 5 test. You did great on that. And guys, we are on the home stretch. This is our last chapter for this semester. It's Chapter 6, and it's going to be all about factoring. So we are just going to be talking about factoring. That becomes my favorite F word in math, is factoring. So let's get started with our joke of the day. Why didn't the Romans find algebra very challenging? Because x is always 10. Think of Roman numerals, okay? So our greatest common factor, definition, it is the highest number that divides each coefficient term of the polynomial. So it's got to be able to go into all of those numbers that are listed in our polynomial. And then the variable is the one that's got the lowest power, because think about if you have an x to the fourth power and an x cubed, then x cubed is going to go into both of those. So, but not x to the fourth, because there's not four of them in x cubed. So it's always the lowest power that appears in all of the terms of the polynomials, and that's the sort of the key, is that it has to appear in every single term of that polynomial in order for us to have that greatest common factor. So if we're going to, when we talk about factoring, that means we're putting something in product form, which is multiplication, right? You remember that? So we want to put it in a multiplication form instead of just, some term plus or minus another term plus or minus another term. We want to put them so that it's something multiplied by something else. All right, and so then we're going to remember that if it cannot be factored, then it is considered prime, and so that is sometimes just your answer, is that it is prime. Okay, so let's look at just two random terms here. So we've got 18x cubed and we have 15x squared. So let's think about all of the factors of each one of these numbers, and then we'll see what is our greatest common factor. So we're given the number 18 and we're given the number 15. Well, let's think about all the numbers that go into 18. Well, 1 obviously goes into 18. 18 is divisible by 2. 18 is divisible by 3. It is not divisible by 4. It's not divisible by 5. It is divisible by 6. It's not divisible by 7, by 8. It is by 9, and then 10, 11, 12, no, nothing up until 18 again. So those are all the factors, and sometimes we would write them as, you remember, 1 times 15 when we're doing the 15. Okay, so 2 doesn't go into 15. 3 goes into 15, so we could say 3 times 5. 6, 7, no, 3, 4, 5. Okay, so we're back to 5, so that's all the factors of that. So what is the greatest one that's in both of those? Well, it's going to be the 3. You see that? How the 3 goes into both of those. That's our greatest common factor for those two numbers. But what about the x squared? The x cubed? And the x squared. Well, remember that it's always that lowest power. And here's why. Because if I say I have factors of x squared, well, that's only x squared and x. Factors of x cubed, I've got x cubed, and then x squared will go into it, as will x. Well, then that's my highest one, is always the lowest power, if you just notice that. So the GCF for these two numbers, 18x cubed and 15x squared, is 3x squared, because both numbers are divisible by that. Okay, so let's look at some more. All right, now we're given 3 numbers, so we've got to think about factors of negative 20, factors of 12, and factors of 40. Okay, so let's see, we can list any of these as negative, so we're just going to list all of our factors of 20. So we have 1 times 20, 2 times 10. 3 doesn't go in there, and then we have, whoops, I just said 3 doesn't. I can't talk in rights. And then 4 times 5. So those are all the factors of 20. Let's list our factors of 12. Well, 1 times 12, 2 times 6, and 3 times 4. What about 40? And you can do that either way. You just notice I'm putting both what it's multiplied by to get that number. But if you wanted to list them the other way, that's fine. So I'll do that one on the 40. So 1 goes into it, 2 goes into it, 3 does not go into 40, 4 does, 5 goes into it, 6 does not, 7 does not, 8, 9, no, 10 does, 11 does not, 12, you see it just gets easier if you list what they are multiplied by, because then I think you're up to 20 after that, and then 40. Okay, so what is the number, the highest number that goes into all 3 of these terms? And it has to be all 3 of them. Well, 1 goes into all of them, 2 goes into all of them, but it's not the highest one. But 4 goes into all of them, and that is the highest one. So we want to use 4 as our GCF, and then we're going to look at our x squared, our x to the 4th, and our x cubed. And we just remember that it's always the lowest exponent. So x squared would be the GCF of those 3 terms. All right, so let's practice factoring a monomial from a polynomial. Well, remember when we were multiplying these things and we said, okay, well, 3x times x plus 2, right? And if we wanted to expand that, then we would distribute that 3x to everything in here. So 3x times x is 3x squared, and 3x times 2 is 6x. Well, now what we're doing is we're taking this form and we want to put it into this form now, okay? Because this is a product. You see how we're multiplying 3x times x plus 2. This is just a polynomial. Okay, so we want to take this and we want to say, okay, what is my greatest common factor between 6 and 18? Well, if we still need to come over here and list out our factors of 6 and 18, let's go do that. So 1 times 6 and 2 times 3. That's all that we have. Well, which one of those numbers is going to go into 18? So we have 1 times 18, 2 times 9, 3 times 6. And that's all. So our highest one is 6. Well, notice we have an x squared here, but we do not have any x's here, so we cannot take out any of those x's. So we're just going to say that the GCF of these two terms is 6. Well, what happens if we take 6 out of both of those terms? Well, it's like you're dividing. So we're going to say 6x squared plus 18. I'm just going to rewrite that here. If I'm taking this 6 out, it's like I'm dividing that 6. So what's left? Just the x squared. Well, what happens when I take the 6 out of the 18? I have plus 3. So there is that expression written in product form because it's 6 times x squared plus 3. You can always go check your answers by multiplying that back out. So 6x squared times 18, so you know that you are correct. Okay, so let's look at this next one. We've got 25x squared plus 35x cubed. What is the GCF between 25 and 35? If you need to list those out, you can do that. I'm just going to tell you that GCF is 5. 5 would be the highest number that can go into both 25 and 35. And then we have an x squared and an x cubed, and we always use the lowest exponent, so that is x squared. So if we're going to write this as a product, we're going to say we've got 5x squared, and we're taking that out of each term. So it's like dividing both of those terms times 5x squared. So 25 divided by 5 is 5, and x squared divided by x squared is just 1. So 35 divided by 5 is 7, and x cubed divided by x squared means, remember, we subtract those exponents, 3 minus 2, so we still have an x left. And you can check that answer by multiplying it back out. Okay, so now we've got 15x to the 5th plus 12x to the 4th minus 27x cubed. Well, we've got the numbers 15, we've got 12, and we have negative 27. Well, what number is going to go into all of those? So we're going to list out those factors. So 27, 3 times 9. That's it. So what is that? 3 then? 3 is our common one. So we've got our GCF, our greatest common factor is going to be 3. And then since they're all x's, we can say x cubed is in every one of those. So let's take out that 3x cubed out of each one of these terms. And hopefully you have this. I'm going to erase it so that I can show you the division part of that. Divide each term by that GCF because we've got to be able to take it out of every term. So 15 divided by 3 is 5. X to the 5th divided by x cubed leaves us with x squared. And then 12 divided by 3 is 4, and x to the 4th divided by x cubed is x. 27 divided by 3 is 9, and x cubed divided by x3 is 1. So that is just 9. So make sure you check those answers by multiplying it back out, distributing that 3x cubed back out, and making sure you come up with the original expression. Okay, so look at this crazy one. We've got 8x cubed y squared minus 14x squared y plus 2xy. Okay, so let's just take one step at a time. Between our 8 and our 14 and our 2, what is that GCF? What is the greatest common factor of all those? Well, having that low one as a 2, that pretty much means 2 is only 2 times 1, so it's got to be 2. And 2 goes into 8, and it also goes into 14. Okay, so now let's look at our x values. We have an x cubed, we have an x squared, and we have an x. So what's the lowest exponent that's going to go into all of those? Just x. And same thing on our y's. We have y squared, y, and y. So the lowest exponent there is just the y. So now let's rewrite this expression as a product, taking out this 2xy out of every single term. Well, 8 divided by 2 is 4. X cubed divided by x is x squared. Remember, you're subtracting those exponents. And y squared divided by y leaves us with just y. All right, next term, 14 divided by 2, that leaves us with 7. The x squared divided by x leaves us with x, and y divided by y is 1, and we don't need to write that. Plus, what is 2xy divided by 2xy? Well, you might want to think that that's 0, but that would not be right. It's always 1. Remember, you've got to be able, anything over itself is always equal to 1. And since we don't have any other numbers there, we've got to write that 1, because remember, we've got to be able to multiply this thing back out and come back to the original equation. And if we didn't leave anything there for that one, when we multiply it, then it would not show up, and we need that one to be in there. So we've got to have that 1 at the end if there's nothing, okay? So If the first term of the polynomial is negative, then you always want to factor out a negative GCF because we just like our first terms to be positive. That's just, standard rule. I don't know why. We just like them to be positive, so we're always going to factor out a negative GCF. Okay, so let's look at this one. We've got 18, or negative 18, a 9, and a 6. So what's going to be the common number that is each one of those is divisible with? Well, if you said -3, you are correct. Okay, so what about our x values? What's the lowest exponent? We have x to the 4th, x cubed, and x squared. Well, it's going to be x squared. So now we're going to take out a -3x squared out of each one of these terms. And remember that we are dividing by a negative number, so that's going to change a lot of those signs in there. So -18 divided by -3 is a +6. X to the 4th divided by x squared gives us x squared. And 9 divided by -3 is -3. And we have an x left. And 6 divided by -3 is -2. And then the x squared over x squared is just 1. But since we already have the 2, we're good. All right, so that's it. Final answer on that one. Just always keep that in mind. If that first term is negative, we want to factor it out, and that's going to change all the signs in that leftover polynomial. All right, so do this one. Let's see what you come up with on this, and check your answer. So this is what I got as the GCF. And if I go divide this out of every term, I'm going to get that's it. So hopefully you got the same answer on that when you tried that one on your own. Okay, so the last thing on this video that we're going to talk about is factoring by grouping. So it's one of the easier ways to factor a binomial out of or just factor, I guess, a polynomial. But we're going to use grouping whenever we see a 4-term polynomial. Okay, and so we remember that that means there are 4 terms in there. And then when we do that, we're going to find the GCF of the first 2 terms, then we're going to find the GCF of the last 2 terms, and then hopefully that will create some kind of common binomial then that we can factor out. All right, so look at this first one. I just want to point out that in this case, this thing is one whole term and this is another whole term. Well, what do those 2 terms have in common? They both have this x plus 1 in common. So it's like we can factor out that x plus 1. We're just factoring out the whole little binomial there that this thing has. So let's look at that and say, okay, well, just like in their other example, if we divide both sides of this by x plus 1, what's left? Well, in this case, the x squared is left for that term, and then the 7 is left for the other term. And so we've put that in product form and we factored it, and that is just a nice, easy way to remember to factor. Okay, and so a lot of times when I'm teaching this, I'll say, okay, look, you've got this common factor that's inside the parentheses. Well, that is to both terms. So we're going to take what's inside the parentheses and then multiply it by what's outside those parentheses. Because if we just take that y plus 4 out, we're left with that x minus 3. You see that? Here's the x minus 3. because both of those are multiplied by that y plus 4. And remember, when we factored or we multiplied these polynomials before, then we would take that first term and multiply it by everything in the other term. And so that's exactly what you're doing here. All right, so now let's try one from scratch. Okay, so remember, if we're going to factor by grouping, it's like we're going to cut this thing in half, and we're going to say, what is the GCF of just these first two terms? Well, that's an x squared. Then what is the GCF of these last two terms? Well, that's a 2. Well, what happens if I say, okay, let's take that x squared out of the first two terms? So I'm going to divide this one by x squared, divide that one by x squared. That leaves me with x plus 5. Okay, well then I'm going to take this, the last two terms, and we're going to say, okay, well now I'm taking this 2 out of these last two terms. So let's take both of those and divide by 2. Well, that also gives us x plus 5. And we say yahoo, because now we've got a common binomial that we can take out of the rest. You see, this is not in product form yet because of this plus sign here. So we want to take out the x plus 5. And what are we left with? If we divide this term by the x plus 5, we're left with the x squared. If we divide this term by the x plus 5, we're left with that plus 2. So now it's in product form, and we consider that as factored. Okay, you want to try the next two? Or is that all you have to on your own? Stop the video, pause it for a second, try your 2. Okay, GCF of these two terms is x, and GCF of these two terms, and remember, leading coefficient is negative, so we are going to take out a negative 5. All right, if we take out the x out of the first two terms, we are left with y plus 3. If we take out the negative 5 out of these last two terms, then we are left with y. And look at this, we're taking that negative, we're changing those signs because we're taking out the negative 5, y plus 3. Then once again, we can do a happy dance because now we have a common binomial that we can take out of both of those terms, leaving us with what is on the outside of those parentheses, x plus 5 there, or x minus 5, sorry. And that does not matter. If you write your answer as x minus 5 times y plus 3, that is the exact same thing. So it doesn't matter, because remember, as long as what's inside here matters, but the order of your two binomials does not matter. Okay, last example, we have a GCF here of 5x. And what about this one? Well, we don't have a GCF there, but we might need one, so let's just take out a 1. And that's okay, we'll take out a 1. So let's take out a 5x on the first. That leaves us with 2x plus 1. And look, we notice that this is already the same as this. But we've got to say, let's pretend like we're taking a 1 out. That's not going to change anything, so that we get these common binomials at the end here. So we want these two things to sort of match, but there has to be something out here in front of it in order for them to do that. So then we can say 5x plus 1 times the 2x plus 1. Okay. All right, and that's your final answer. So hopefully you won't have too much trouble with that. We'll get into some more factoring in our next video.